looking at the Earth from space, you realize what a precious place this is.
You realize that we have a responsibility to continue safe operations on board Spaceship Earth. And that means protecting humanity.
Asteroid impacts are tremendous events.
If they hit Earth, bad things can happen. And so, for example, the asteroid that hit in Tunguska in 1908 was about 40 meters across. Okay, and that caused an area of devastation roughly the size of the San Francisco Bay Area. There's a million or so objects whose orbits cross Earth's orbit. And we currently know of about 10,000 of them. Our project, called Sentinel, is to launch a telescope, a space telescope, to catalog and track and make this map of all the asteroids in the inner part of the solar system.
Sentinel relies on an infrared telescope that's about a half meter in diameter. And the reason infrared is important is because asteroids glow at a certain wavelength. And we've built the telescope and the camera so that it just sees that wavelength.
And what it will do is orbit the sun, looking away, and map areas of the sky. And then it will remap those same areas about an hour later, and then later in that day we'll do it again, and then later a few days later, and then later a month later we'll do those same areas again. And it will look for the objects that move.
We save that data and send it to the Earth. And here on the ground, we have software that'll allow us to link together these moving objects and try and figure out what their orbits are so that we know where the asteroids are.
The nice thing about asteroids is that once you found them and once you have a good solid orbit on them, you can predict 100 years ahead of time whether there is a likelihood of an impact with the Earth.
We should start building Sentinel in the late fall of 2012 timeframe, and it'll take us about 4.5 years to build it. So we're thinking about approximately 5 years from now we'd be ready to launch Sentinel. Then Sentinel will run for about 5.5 years doing its mission mapping out the asteroids.
The first thing that we'll use the map for is to scan ahead and see if any of those orbital tracks puts it in a location where the Earth is at the exact same time, because that means there's a collision coming up. So if there is going to be a large collision coming up, we will know about it with enough advance notice, decades, that the job of deflecting it is actually not that difficult. On average, the amount of velocity change that you need to give to an asteroid to keep it from hitting is something like 1 millimeter per second. So, if an asteroid is moving, say, 100,000 miles per hour around the sun, then I can make its speed 100,000 miles an hour plus this much. That can prevent the impact. The second thing we will do is it will give us a list of all the places we might care to visit, either through robotic missions or through someday, hopefully, human missions. And this will again be the definitive map of where all those things are. We've been given a gift. And the gift is that we have the ability now to go out there and actually do something which affects positively the future of humanity on Earth. And that's a gift you can't turn down.
Well, we feel a certain urgency to get on with it so that we can be confident that we're not going to have a cosmic disaster here for no good justifiable reason, just because we didn't get with it. So let's get with it. That's the name